Welcome back. Now that we've taken a look at the different tools that we have, either in the VAMI of your vCenter or in Vim Tops output, we took a quick look at where we can find CPU metrics, but there's also memory and networking. And so let's take a look at some of those. In the Vim Top report, you can basically look at the main screen, the processes view, which shows all the processes, all their CPU usage, and of course their memory usage, telling us the percentage of memory that each of the different services are consuming, the amount of megabytes that they are consuming in vCenter memory, as well as how much virtual memory that may be actually sitting in the swap file of your Linux OS. So we can see here the vSphere H5 client, right? That would be the real name of the vSphere client written in HTML5. That's why it's written as the vSphere H5 client. That's the server, right? The web server on the vCenter server. We can see here it is using roughly 678 megabytes of memory. Now, remember, and that's a Java process. We found earlier that if there is a high CPU usage in the system, and you're finding that it's a Java process that's using lots of CPU. This doesn't seem to be using lots of CPU, right? You notice the number there is like 0.37%. But if the Java process is consuming lots of CPU, you might consider adjusting its heap size. So how do you find out what that is? Well, you can actually find that out from another command called cloud VM RAM size. -L will list all the services that are running on your vCenter server, and we'll show you what their RAM size is. In this example, the vSphere client, which is actually what it's called, is using 853 megabytes of memory out of a grand total of 10,000 megs. Actually, that's not the name of the client. The name of the client is actually vSphere-UI. That happens to be an older name for it. But anyway, the name of the client today is vSphere-UI, and we can see this one's using 853 megabytes of memory. But that's all of the memory. If you want to dig a little bit deeper, run cloud VM RAM size -J and the name of the service. In this case, it's actually called a vSphere-UI. That is correct. And you can see it was 853, but wait a minute, 597 megabytes is actually what's being used for the heap of that machine, of that service, right? And then we have compressed class space size is 256 megabytes. And we have some extra SSS, which is set to 320K. But we can see here in this particular process, it's using 597 megabytes as its heap. So again, why were we concerned with this? This is if you have a case where the vCenter server is using consistently high, over 70% CPU, and you're looking at who's consuming the CPU. If it's the VPXD service, you really just need to give more CPU to the vCenter VM and call it a day. But if it's a Java service that's using lots of CPU, like the HTML5 web server, then you might consider bumping up its heap size. So how do you actually do that? You can find out what the heap size is with the cloud VM RAM size -J and the service name. And then to actually change the heap size, it's cloud VM RAM size -C, the new size you would like to set it to, and the name of the service. So in this case, we're changing the vSphere client service to a new heap size of 700, and you can actually verify what it has been changed to by running the cloud VM RAM size -J again to see if it's been adjusted. Now, where this can actually sometimes be also useful is that since the memory is hot pluggable, you might bump up the memory on that vCenter server, and then that won't readjust all the memory settings across all the services. All it did was just give more memory to the Linux OS. If you've given the VM more memory and you didn't want to reboot your vCenter server, because that usually will recalculate all the memory sizes for us automatically, but instead, if you want to just update the memory without rebooting and now go and update the heap sizes on all the different services that seem to be consuming CPU, that's another approach. And that's maybe a reason to run a command like this to change the heap size without rebooting. All right, what else do we have? Networking performance. To see the vCenter server's networking performance, that's very important because vCenter is hitting the network quite a bit between each of the different vCenter nodes, right? If you have enhanced link mode, the different vCenter servers will be communicating with each other quite significantly. This is where they do their lookups across the different inventories. And of course, vCenter needs to communicate with its ESX servers, but it's actually more critical for vCenter to communicate with other vCenters, believe it or not. So in any case, we want to ensure that is, an optimal working network. In fact, we make note of this. It says host-to-host network bandwidth is typically more critical than vCenter server to host bandwidth. What are we referring to here? I know they say host-to-host, and that's not really what is the thing that we should be referring to here. It's not ESX host to ESX host. They don't really talk to each other very often. They do. I mean, there's heartbeats for things like HA and vSAN and stuff. But what this is referring to is vCenter host to vCenter host. When you're in enhanced link mode, those vCenters communicate quite significantly with each other, especially while looking up the inventory objects across the distributed enhanced link mode environments. Right? When you have the vSphere client open and you see all the vCenter servers in the interface, we're learning about all those vCenter servers inventories by communicating from vCenter to vCenter. So that bandwidth is actually very important, more important than, in fact, vCenter to host. Because, when you make a request to do something on a host, the latency is usually on the host itself. We send a command down to the host to do something, the host goes and does it. The host needs the resources to do that thing. Like, for instance, provisioning a VM requires to provision a disk, right? Or at least to create a virtual disk and so on. Well, that's where the latency is. It's at the host level to provision the storage. All vCenter had to do is send a command. There's a couple back and forth, but there's not a lot of bandwidth there. It's really down at the host level. When hosts do communicate with each other, it's when hosts are cloning VM from, say, one VM to another, deploying a VM from a template, right? The provisioning process does involve host-to-host bandwidth. So that's where it's important, as well as from vCenter to vCenter. So as it says here, in most cases, operation latency is bound by host latency. So when the operation is from vCenter to a host, the latency is probably at the host level. Not really the network from vCenter to the host is what this is trying to say. So monitoring networking activity, we can check that from the VAMI. We can, in that same monitor section, we drill over to the networking tab, view all the different networking statistics. Certainly we want to watch out for drop packets on the vCenter servers, virtual NICs as well. And we can also monitor network activity from the vimtop utility. This is with the letter K, right? Oh, so that's, the letter O will take you to the networking screen. And you can measure each of the different network adapters on your vCenter system, measure the networking rates, the receive rate, transmit rates. But what's important, of course, are the drop packets and the errors. We don't want any. Otherwise, there's significant congestion going on within maybe the ESX server that your VM is running on. And then what about the database, right? It's critical that the database is working optimally, right? Now, again, since the database is on the same system as vCenter, there will be times when rolling up statistics is going to cause a spike in your resources. We call those transient high CPU usage during rollups. Totally normal activity, right? Under normal vCenter usage, the database resources such as CPU, memory, disk, and networking should not be saturated. Right? The entire vCenter server should not be saturated. If it is, it's time to add more resources. Right? Consistently high CPU is not normal. The following symptoms occur with high CPU usage: rollups or top-end calculations. Again, this is more of a transient thing, and historical queries of large inventory might be so. That could also be an indicator of an issue. The database performance also you may need for the Postgres database, recompute the database statistics on database tables. You can set the retention policy for the different database tables using the vSphere client. Purge the database tables, lower the retention policy. These are things that we can adjust. You also need to verify on the vCenter service command line the VPXD log. This is all under var log, and you'll find the VPXD log, the database log, and the database partition sizes, and the seat tables. Check to make sure everything isn't reporting anything unusual. And also make sure that the database has not run out of disk space. Or if it is running low on disk space, that's a problem. Right? If you're using third-party tool, which uses the vSphere Web Services SDK, right? Or even something like vRealize Operations, they're going to go and query this database. You'd want to verify, the third-party queries are optimally configured. Check your events, the tasks, and the stats tables. These are all parts of the logs on the vCenter system. If you see slow rollups or top-end calculations, you may need to add virtual CPUs to that vCenter VM. You may need to add memory and verify those rollup stats. But check to see whether or not are those resources completely saturated to basically kind of justify whether or not adding those resources is what you need to do. So one thing to note when it comes to the database, the statistics level that you choose is also a pretty big factor. You set this on your vCenter server settings page. You set what stats level you want it to record in. It normally is at stats level 1 or stats level 2. But anything higher than that, stats level 3, stats level 4, that's going to cause quite a bit of overhead in saving metrics into the database. Stats level 1 and 2 save a minimal amount of metrics. What this is showing here is if I happen to have an environment that was a small environment, but I had an ESXi host with 48 CPUs, probably 48 core, probably 48 hyperthreads, and we got 2 VMs. Each VM has 2 virtual CPUs. Each of the VMs have a certain number of disks. It looks like VM1 has 11 disks, VM2 has 1 disk. The host itself sees 13 virtual disks. The data stores, there's 1 data store for each of the different VMs. The host itself sees 9 data stores. The VMs all have 1 network adapter. The host has 3 network adapters. If you leave it with stats level 1, the amount of metrics to store is relatively easy to manage, but raising your stats level raises these metrics potentially quite significantly. And so that's why we recommend not to raise these stats levels to anything higher than 2 for any extended period, right? Just for troubleshooting maybe, and then that's a good case for then, once that's over, to set them back to level 1. So that was a quick look at the other resources, network, memory, and database. We'll take another break here and we'll come back and look at other areas to monitor in our vCenter system. So stay tuned, we'll be back in a few moments.